Okay, now we have two regular polygons that we already have formulas for, right? The two that we just saw in that last kind of example, and that is an equilateral triangle. If we're dealing with an equilateral triangle, you simply use the formula that's simpler, 1/2 base times height. And if we have a square, simply use the area formula for a square, which was s squared. Okay, so once again, we can see on here s represents the side length. Okay, once you get beyond this, though, so let's say we go into a regular pentagon. Okay, once we're dealing with regular polygons that have 5 or more sides, you're no longer going to have a specific formula that we've already talked about, but there is a formula that applies to these. Okay, I want to derive this formula for you so you can see it. Okay, so let's say we take the and find the area of a regular pentagon. And let's say we're given that the side length is 10. Okay, for any regular polygon, you're going to do the same steps. Okay, so I'm going to show you solving it for a pentagon, and then I'll broaden it and show you what the overall steps or formula is. Okay, the first thing to think about is when you're dealing with a regular polygon, all regular polygons have centers. The center of a regular polygon is also the center of a circle that will pass through each vertex of that regular polygon. Okay, so that circle circumscribes the regular polygon. And the reason that that's important is if we now connect the center of that regular polygon to each of the vertices of the regular polygon itself, those are all also radii of the circle. Okay, so what that tells you then is that these measures are all the same because the radii, all radii of a circle are identical. Okay, so let's say we take our regular pentagon with a side length of 10. Okay, how many of these isosceles triangles are created as we encircle the center of this polygon? 5, and it's equal to the number of sides, right? So if you look at n being the number of sides in a regular polygon, the number of triangles that can be formed here are going to be the same as the number of sides. So what other information can we find out about one of these triangles? So if we just take one of these reference triangles, we know that here, and let me kind of bring this out. Okay, so the side is 10. We know that this is an isosceles triangle. Is there anything else that we know about this triangle, these reference triangles? Doug?
Well, if you divided 360 by 5, you get the list, actually.
Good. So we want to find this angle measure. Right? And this angle measure, it can be found by taking the full rotation 360 divided by whatever number of triangles you have in there. And so that number is always going to be the number of sides. So if you take 360 divided by 5, you get 72. So we know now that this vertex angle of the isosceles triangle, our reference triangle, is 72 in this case. So if I wanted to find the area of this triangle, I could simply take 1/2 base times height. Well, my base is 10. My height, well, when I draw in my height, what's that height going to do to that vertex angle? Bisects it, right? So this angle up here is going to be 1/2 of 72, or 36. And what does that height or altitude do to the base of our isosceles triangle? It cuts it in half as well. So it bisects the angle, bisects that opposite side. So this length will be a 5. And so now when I want to find this height, this h value, I can do it using this right triangle. Okay? I have a right triangle, I have an angle of that triangle, I have an opposite side, and I have an adjacent side. What trig ratio relates opposite and adjacent? Josh?
Tangent.
Tangent. And so I can set up a tangent ratio. The tan of 36 is equal to opposite 5 over adjacent h. And so now I can simply multiply both sides by h, and then isolate my h here by dividing both sides by tan of 36. And so my height winds up being 5 divided by tangent of 36. Okay, so that's my area for one triangle. Well, how many triangles do I have in this whole regular polygon? 5. So what can I do with this area formula right here? If I take this and I multiply it by 5, the number of triangles in that figure, I get my total area. Okay, so let's take a look at what we did to find this area. Okay, the area for any regular polygon is going to be the area of the corresponding reference triangle. So 1/2 base. Well, the base of the triangle corresponds to the S value, the length of the side in that triangle, or of the regular polygon, times the height of that triangle. Well, the height of the triangle is given as A. A represents the apothem. An apothem is just the perpendicular distance from the center of a regular polygon to its side. Okay? And so it winds up being, and again, because it's represented by the letter A, just think of it as the altitude of that reference triangle. So we have 1/2 SA, that's the area of one triangle, one reference triangle. And then how many reference triangles do we have in any given polygon? And the number of sides. So here is your area formula. This will give you the area for any regular polygon. Okay, so if we were to take this problem that we did down here, we have our 1/2. Our S value was the length of the side 10. Our A value was 5 over the tangent of 36. And our N value was 5 because it's a pentagon. So we'd simply calculate that out and we'll get our solution. So 0.5 times 10 times 5 divided by the tangent of 36, all times 5 once again. And our answer winds up being approximately 172.05 square units because we're dealing with a two-dimensional area.